The Purification System. The production of flour from conditioned wheat can be divided into three parts: the break, purification, and reduction systems. This chapter is about the purification system. In this chapter, you will learn about the purification system and how purifiers work. The purification system. The purification system collects semolina from the break system and, after segregating into grades based on size and purity, distributes it to the appropriate parts of the reduction system. The system is mostly made up of purifiers and may also include finely fluted rolls called scratch rolls. The purifiers are usually all located together on the same floor. Scratch rolls are located on the same floor as all the other roller mills. The semolina from the break system is segregated by purifiers. The purifiers will segregate the semolina by size and purity. After purification, some of it is mostly pure endosperm particles. Some of it is mostly bran particles, and some is mostly composite particles consisting of bran and endosperm joined together. There will also be some germ in the mix, but germ extraction is beyond the scope of this course. The pure semolina will be sent to the beginning of the reduction system for grinding. Very clean flour streams are produced at these passages. Larger particles may be sent to different rolls to allow more accurate grinding. Bran-contaminated stocks will be sent to the end of the break and reduction systems, where the bran powder produced during grinding will not contaminate the cleaner flour streams. Small composite particles may be sent here too, but the larger of these composite particles will be sent to the scratch rolls, where the finely fluted rolls can scratch the bran and endosperm away from each other. The scratch roll stock will be sifted to remove any material too fine to be purified, and the remainder sent back to different purifiers for segregation and grading. Purifiers. Purifiers segregate semolina by size and composition. They need to be fed by pre-sifted stock, as each purifier is designed to handle a specific particle size range of semolina. The stock passes through a feed mechanism, which spreads the stock over the full width of the machine. The stock then passes over a vibrating sieve deck. The deck consists of 4 sieve frames in series, each with progressively more open apertures. The vibration helps the stock to move forward along the deck, but also to stratify by size. As the screen vibrates, smaller particles tend to fall to the bottom of the mass. Particles that are too small can actually prevent this segregation by causing the stocks to stick together. Therefore, stocks destined for the purifier must be well sifted to remove their stickier, undersized particles so that they do not reduce the free-flowing nature of the semolina or impede the movement of the semolina along the screens. The screens in each deck range from fine screens at the beginning to open screens at the end. These screens may be kept clean by balls or brushes which move up and down the screen. Many purifiers have double or triple decks. As the shaking action causes the stock to stratify, the smaller particles at the bottom of the mass fall through the screen first. While all of this is happening, air is being drawn up through the screens. The particles differ both by size and by composition. Some particles are composed of mostly endosperm, others mostly of bran, others could be equal parts of both. These particles differ in composition and so are affected differently by the air current. Since bran is lighter than endosperm, particles containing more bran will lift above the heavier endosperm particles. The more bran they contain, the higher they lift. This process stratifies the stock by both composition and size. Some particles of pure bran are small and light, enough to be lifted out of the mass and into the dust collection system. As the screen apertures towards the end gets larger, so the particles falling through the screen also get larger. Since the branier particles are held up higher, the endosperm particles fall through before the brany particles of the same size. So, the stock towards the end of the purifier becomes larger and contains more bran. The larger stock containing the most bran tails the last screen. The screens in the top deck of a multi-deck purifier are the most open. Each deck below is slightly finer, so the tails of each of these screens will be slightly finer and contain less bran. The throughs of the bottom deck are a spectrum of stock types from fine and pure at the head end to coarse and moderately brany at the tail end. The throughs at the head end should be mostly endosperm. The tails of the top deck should be mostly bran, while the remaining stock should be somewhere in between. There are two collecting channels below the bottom deck, each directing the throughs to different outlet spouts. Flaps in these channels control which channel the stock lands in. The flaps can be adjusted and used to create the optimal split of stock to the appropriate outlet spouts. These channels vibrate along with the decks to cause horizontal stock movement to outlet spouts. Above the decks, air channels are positioned over sections of the screen so that the air current strength can be optimized for each section. Air strength should generally be set so that it is weakest at the first screen and strongest at the last screen. The air should be strong enough to cause the stock to bubble slightly, but must also be even across the full width of the screen. There must be enough stock to cover the full width of the screen, or the air will rush through the uncovered section and do nothing in the covered section. This chapter has covered the design of Purification System and how purifiers work. The quiz that follows will help you to confirm your knowledge.